For more than 100 years, Earth has been sending invisible messages into space without ever meaning to. These messages are not letters or spacecraft. They are radio waves, a type of energy that moves at the speed of light. Every time humans used early radios, televisions, or radar systems, some of that energy escaped Earth and began traveling outward into the universe. These signals did not stop when the broadcast ended. Once released, they kept moving, spreading farther and farther away from our planet. Scientists often describe this expanding reach as Earth's radio bubble. The word bubble does not mean a solid wall or a clear boundary. It simply helps us imagine how far our signals have traveled since we first learned how to broadcast them. Like ripples spreading across a pond after a stone is thrown, Earth's radio signals have been spreading through space, becoming weaker as they move farther away. The story of Earth's radio signals begins in the early 20th century, long before satellites or the internet existed. In 1906, a man named Reginald Aubrey Fessenden made history. On December 24th of that year, he carried out the first known radio broadcast meant for ordinary listeners. Until then, radio communication mainly used Morse code, which was a series of dots and dashes. Fessenden did something new and unexpected. He spoke into a microphone, played a violin, and read a passage from the Bible. People working on ships at sea heard his voice and music through their radio receivers. They were surprised and amazed, but none of them could imagine that this moment marked the beginning of humanity's voice traveling into space. When Fessenden stopped playing and speaking, the sound faded for the listeners. But the radio waves themselves did not disappear. They continued moving outward from Earth at the speed of light, about 300,000 kilometers per second. That single broadcast became the first thin layer of Earth's radio bubble. To understand how far Earth's signals have traveled, it helps to know what radio waves actually are. Radio waves are part of the electromagnetic spectrum, which also includes visible light, X-rays, and microwaves. They do not need air to travel. This is why they can move through the empty vacuum of space. Once a radio wave is created, nothing stops it unless it hits something that absorbs or blocks it. In space, there is very little to stop it. So radio waves can travel for millions or even billions of years. However, as they spread out, they become weaker and more spread thinly across a larger area. This weakening is very important for understanding why Earth's signals are difficult to detect from far away. Earth's radio bubble is the region of space that has been reached by radio waves sent from Earth, because radio waves travel at the speed of light. The size of this bubble depends directly on time. If Earth has been broadcasting radio signals for about 119 years, then the radio bubble has a radius of about 119 light years. A light year is not a measure of time. It is a measure of distance. 1 light year is the distance light travels in 1 year, which is about 9.46 trillion kilometers. So when scientists say Earth's radio bubble is 119 light years wide, they mean that our earliest radio signals are now that far away from Earth. This does not mean the bubble is strong or clear. It is more like a fading echo. The farther the waves travel, the weaker they become. There is no sharp edge where the bubble suddenly ends. Instead, the signals slowly blend into the natural background noise of the universe. When people imagine space, they often think in human-sized distances, but space is unimaginably large. Our home galaxy, the Milky Way, is about 100,000 light years across. Compared to this enormous size, Earth's radio bubble is tiny. Even after more than a century of broadcasting, our signals have barely left our local neighborhood in the galaxy. If you imagine the Milky Way as a vast ocean, Earth's radio bubble would be smaller than a drop of water near the shore. This comparison helps explain why space feels so silent. Even though humans have been sending signals for over 100 years, those signals have not had enough time to travel very far on a galactic scale. Distance in space is so vast that even light itself takes tens of thousands of years to cross the galaxy. Some nearby stars now lie inside Earth's radio bubble. The closest known star system to us, Proxima Centauri, is just over 4 light years away. This means Earth's earliest radio broadcasts passed that star system more than a century ago. Many other stars within 119 light years have also been reached by our signals. In theory, any planet orbiting those stars has been bathed in faint radio energy from Earth. However, this does not mean anyone there has heard our music or voices. A scientific study from researchers at Cornell University identified 75 star systems that are in a special position. These systems are close enough to Earth to receive our radio signals. And from their point of view, Earth would pass in front of the Sun. This means observers there could potentially detect Earth as a planet and also receive faint signs of our technology. Even though Earth's signals have reached nearby stars, the chance of anyone actually hearing them is extremely small. This is because radio waves weaken rapidly as they spread out. The energy of a broadcast that was once strong enough to reach ships at sea becomes incredibly faint after traveling light years through space. By the time Earth's radio signals reach another star system, they are mixed with natural cosmic noise. Space is full of radio emissions from stars, galaxies, and other natural sources. Against this background, Earth's signals are like a whisper lost in a storm. Even a highly advanced civilization with powerful instruments would struggle to separate a human broadcast from the noise of the universe. At best, they might detect a slight hint that artificial technology exists somewhere. They would not hear clear voices, music, or messages. In the early days of radio and television, large amounts of energy leaked into space. Broadcasts were powerful and poorly controlled. This made Earth's radio bubble thicker in its early layers. Today, modern technology works differently. Much of our communication happens through fiber optic cables, satellites with focused signals, and digital systems that are designed to stay close to Earth. As a result, far less radio energy escapes into space. This means Earth's radio bubble is still expanding, but the newer layers are much weaker than the older ones. Over time, Earth may actually become harder to detect, not easier. From far away, our planet could appear to be going silent. Earth's radio bubble is not a message sent on purpose. It is a side effect of a young technological civilization learning how to communicate. It shows us how recently humans entered the cosmic stage and how vast the universe truly is. Our signals are traveling, but they are faint, scattered, and without direction. They may never be noticed, or they may remain as a brief trace of a planet that once began to speak into the darkness of space. More than anything else, Earth's radio bubble reminds us of humility. It shows that even after a century of technology, we are still just beginning our journey into the universe.